So to help you understand how GANs are trained, let's look at a few hands-on interactive examples here. And after this, we'll go through a notebook to go through it in more detail. But a really nice tool for visualizing how this training works is the GAN lab here. And let's talk about what's going on here. So instead of starting off by trying to generate fake images, let's start with something simpler, easier to wrap our heads around. Let's just choose a two-dimensional data distribution here. So what I'm going to do is try to create a GAN that learns how to create a ring. Okay, so we have this distribution of 2D points in this general ring shape here. And what we want to do is train our GAN to take a random input and randomly generate a distribution that matches that as well as possible. So in this visualization, we're going to see the real data points plotted in green. This is coming from our real distribution. And the fake ones being created by our generator will show up in purple as we train. And as the training goes on, we'll be able to visualize in a heat map the loss functions of the generator and the discriminator. So as we go, we'll see the discriminator trying to classify these points as real or fake. And what we should see is that it should eventually converge around sort of a ring shape where it identifies things in the ring as being real and things that are outside of the ring as being fake. And we can actually see over time how well the generator is doing at tricking the discriminator and how good the discriminator is doing at telling real and fake apart. So let's go ahead and kick this off. Just hit play and we can watch it in action. So you can see that our fake data here is kind of like going all over the place here at first as it starts to learn, but pretty quickly it's going to start to fall into more and more of a ring shape. And we can see our discriminator here heat map. So right now the discriminator is saying, okay, fake ones are over here, they're over here. The purple again is fake and green is real. And already we can see that we're getting sort of this ring, this circle here of white here, where it's going to start putting that green real classification around that ring and a purple fake classification everywhere else. And as we go on and on, it should get tighter and tighter. Already we're seeing the generated purple fake samples starting to get more and more within that actual distribution that came from the original real data distribution there. And let's take a look at the metrics over here. So we can see that over time, the discriminator's loss function is decreasing, but kind of holding steady because it's starting to get harder and harder to tell the two apart, right? But the generator's loss function is starting to stabilize here. You know, could be better. Things are getting a little bit wonky here. We can see that we've already sort of maybe hit a local minima there and kind of got a little bit unstable there and it's kind of trying to work its way back to something better. And again, you know, the thing with GANs is that they're very unstable. So it really takes just the right set of hyperparameters for this to work right, and a stroke of luck quite frankly, because, you know, there are some random components to the training going on here. But eventually it does seem to be getting back to where it should be here. I think it's getting out of that and starting to get back to where it wants to be. We have kind of this weird crescent shape going on in the discriminator right now that obviously is not correct. These circular shapes are notoriously hard to learn. And those generated samples are really kind of falling into a line there, not really a circle. It was actually better earlier. Oh, wait, I think we're getting back into a better state here. All right, now we're starting to converge into something that looks a little bit better. Yeah, you can see that starting to stabilize. And we can see in the graphs here that the generator loss function is decreasing. The discriminator's loss function is starting to stabilize. Those are all pretty good signs. But again, you know, not awesome. You know, we can see the overall manifold of the generator here. It's not really that circle shape, but at least it's getting closer. It's kind of falling off the edge here with that distribution. And it can't really seem to get out of that in this case. So we're kind of stuck here, it seems. If we were to start it again, we'd probably, you know, get different results. So let's try it again. Now that we have a better feel of what's going on. All right, so again, we're... the generator is got a little bit luckier this time. We're actually getting into more of that circle shape a little bit earlier on, it seems. And we can see that the loss functions are more or less stable here. Because again, we kind of guessed correctly from the get-go. Still got some of those fake samples in the middle there where they shouldn't be. We'll see if that improves over time. All right, this is starting to look better. You know, that generator manifold there is looking more circular. Discriminator is, you know, still kind of focusing on that upper right quadrant there, but overall the results aren't too bad. And now we're starting to look good. So now the discriminator is really kind of getting that circle shape and learning that, so that anything outside of that circle, it knows it's fake. And at the same time, the generator is starting to get a little bit wonky again. So again, it's unstable, right? So we're learning here that GANs are difficult to train. They can get unstable. Getting those hyperparameters and the number of epochs just right, getting the batch size just right, all critical for good performance. Why don't we try something a little bit simpler? Let's try this data distribution, which is just a straight line. That should be an easier case here, and we can see that the generator is pretty quickly converging on that line there. And we should see the discriminator starting to pick up on that as well. But already the generator is pretty close to the real data. So yeah, that's a lot easier, right? So circles are always hard, but in this case we converged on something much better, much more quickly. And you can see here that the KL divergence really shrunk quickly there. The discriminator loss and the generator loss are basically stable at this point, so I think that's about as good as it's going to get. So if you want to play with this yourself, head over to poloclub.github.io/GANlab, and you can fiddle with this yourself. There are other models here you can try and play around with different scenarios here and see what happens. All right, moving on. Taking this to another level, let's look at the GAN playground here. Go to ryanakano.com, not sure how to say that, /GAN.playground. This is actually using the old MNIST data set instead of those more synthetic data distributions. So in this case, let's go ahead and hit train here. So we're going to be training this to generate numbers, pictures of numbers. And remember, again, with the GAN, we're not training it to generate specific numbers, so I'm not expecting to see a 9 here associated with the 9 or a 6 with the 6. It's just generating numbers in general. So again, there is that mode collapse degenerate state where it just learns to make one number reliably, but hopefully we'll see something more interesting as training continues here. So what we're seeing here visually is how well the discriminator is doing at telling real and fake apart. So these are the real images coming in and the generated images as well, and how well the discriminator is doing at telling the two apart. So we can see right now we're getting 60% or so success rate on identifying real images as real. Actually, all of a sudden it's gotten a lot better. And we're identifying the fake images as fake more often than not as well. Still not great though. Obviously the visual results here are not awesome, but they are visually improving over time. So making a number is a much more complicated task than just making a circle like we were trying to do with the GAN lab before. So you'd expect this to be a little bit more computationally expensive. And we can also visualize the loss functions on the discriminator and the generator here as well. We can see that already, it's kind of struggling to get any better, but give it enough time and it will. If you want to let this run yourself for a while, after about 10 minutes or so, I find that the results get pretty interesting. And already, it's starting to look like numbers. It kind of looks like a 5 there. I don't know. Still some room for improvement, right? That kind of looks like an 8. I don't know. It's getting there, but give it more time and these will look more and more like numbers. And already I think they're kind of improving, right? So kind of looks like a 4-ish kind of a thing there, but give it enough training. And we can see that, slowly but surely that discriminator cost is decreasing. Generator, however, really struggling to improve. Now you can play around with the different, the topology of the network here if you want to, and the different hyperparameters, see if you can do a better job. But it's gonna be tough. But if you do want to play with this interactively, that's one way to do it. Let's stop this and move on to a more fun example. So this is an NVIDIA GAN demo called GoGAN, where they intentionally spelled that with GAN at the end of GoGAN, after the famous painter. And it's using a GAN to just generate fake images of different types of landscapes, right? So if I just hit the button here, it's going to automatically take this segmentation map here that I drew that says I want water down here and sky up here. And it will generate a synthetic ocean and a synthetic sky that matches with those segments that I defined. So I have to agree to the terms and conditions first. And now we should see an image like that. So they have a GAN that's trained on how to make water and one that's trained on how to make a sky, and it just kind of put them together there. It gets more interesting though. Let's actually select landscape here and put some mountains on the horizon. I feel like Bob Ross here. And you can make any kind of landscape you want this way. So, not really going to be getting into any math or neural network topologies here. It's just sort of a fun example of what you can do with GANs. And we got some mountains there. Kind of a weird boundary there between mountains and water. Let's give it some ground there, some dirt. And I'll sort of make that ocean into a lake. I don't want to waste too much time on this. This isn't a painting class. But just to give you an idea of what this can do. And while we're at it, let's put some happy little clouds up there too. How about one there, one here, and one over there. And there we have our little fake landscape. So a little water hole there, surrounded by some dirt, some mountains in the background, and some clouds in the sky, all generated through GANs that were trained on how to make those different types of features in a painting at random, algorithmically. So kind of a fun example there of GANs. All right, so you've seen GANs in action. Let's go into an actual notebook and dive into how these are actually working under the hood.